Hey guys, this is second part of the implementation guidelines. Let's see what we got for this lecture. So the objective of this lecture is two topics, law of Demeter and serialization. What is law of Demeter or LOD? So let me start with an example. Okay, what is the problem in this code? You can pause the video and think about that. Is there any problem here? Uh, we have a class called foo, and we don't care about the instance variables, and we have a method here. In this method, we are instantiating a class A, right? And then we are calling the get object method of the class A, this object A, and from the object B here, whatever it is, we are calling a method. Let's say do something. And this B shows that this method is inside this object B. All right. So yeah, the code definitely, I guarantee that it works and it will be compiled. There is no compilation error, but do you see any other issue here? Yeah, actually, let's focus on this part. Yeah, so I want to say that it is a bad code, right? So why it is a bad code? Okay, so as you see, class foo is aware of the class A. Up to this point, there is no problem. It means that the class foo has dependency to class A. That's fine. But from here, we understand that there is an object. Let's say its name is class B or something. So there is an object which was aggregated inside the class A. Up to this point, there is no problem at all. All right. But after this, we have a problem. It means that we know, I mean the class A or class foo knows that the object B has a method called do something B. What is this? I mean, why it is a bad thing, right? That's a big question. Because because class foo knows how the object A or class A is implemented. That's the problem. How come it is a problem? Yeah. So in other words, we should know, we should not know that how a class is implemented. The only thing that we need to know is its interface. Let's say this is class foo, right? And this is class A. And when I say class, I mean the objects, of course, right? All right. So when the class foo is looking at the class A, the only thing it needs to know is the interface that class A exposed to the outside world. So foo should only see the methods of the class A and let's say visible members of class A. Yeah. So class foo should not know that there is an object here. Let's say let's call it class B, and so class B is here, somewhere here, right? And inside this class B, right, there is a method which is called do something B, right? So this is too much information, and class foo should not know these things. The only things that it needs to know is just calling, the visible members of the class B. So that's the problem. Okay, we should not know too much information. We should not expose too much information. When when the class foo is calling this method, and it knows that there is a method like this is too much information. Okay, and this is whatever the law of Demeter is concerned about that. So what is the law of Demeter? So here's the definition. A class like class foo, a class should only call direct members of other classes, right? So we should not be aware of how the class A was implemented. Okay, so the only thing that we need to know is, yeah, it is okay to know that class A aggregated class B. That's fine. But how we can, that class B has a method, that's too much information. Okay, so that's the problem. And this is called also the principle of least information or least knowledge. All right. Okay, so we don't like this. We don't like to know this kind of thing. All right. Okay. So this law, as we mentioned in the previous slide, is tied to the concept of dependency. And we know that the dependency or coupling is the same thing. Yeah, so you remember we said, when we were talking about the dependency, we say, okay, we will get back to this dependency the guy, and we will add some other stuff. And now it's the time. Okay, but before that, let me quickly refresh your mind. What was dependency again? So we will have a flashback to the previous lecture. So dependency, technically, when we say class A has dependency on class B, it means that class B is mentioned somewhere in the class A, right? That somewhere can be one of these four places. And also we learned that dependency, even though it is unavoidable, but we need to minimize that. Okay, so this is our goal. So this is a design goal. All right. We'll also learn that, in the I mean, object-oriented design terminology, there are other equivalent terms that we might be using. For example, class, A uses class B. So the uses, it means that there is a dependency. Is dependent on, has dependency on, is coupled to class B, class A. I mean, class A and class B are coupled. So all of these, terminology terms can be used to show that there is a dependency. All right. So this coupling, yeah, let's focus on this coupling, because I want to introduce two new terms about this coupling. So this coupling, when two classes are coupled, so class A and class B, so class A has dependency to class B. This dependency has some degrees, right? This is a new thing now. We have a degree of coupling, right? So when we say, when we say class A has dependency on class B, we want to conceptually define that in a plain English, we might use other terms as well. So, for example, we can say class A is aware of class B. It means that there is a dependency. Class A has dependency on class B. So to be aware of is another phrase that we can use. Another one is, yeah, class A has information about class B. Again, the same thing, or knowledge, or we would say class A knows about the existence of class B. All of these terms means class A has dependency on class B. So, as I said, there is a degree of the awareness, how much class A knows about class B. How much it knows, that's the problem. That's the actually our focus here, right? So it has some degrees. Let we divide this concept of the awareness concept, or the degree of coupling of two classes. We divide it into two parts. So, in other words, in general, we have two types of coupling. All right. So we called one of them is loose coupling and the other one as tight coupling. So let me define each one clearly. So what is loose coupling? So this is the definition of loose coupling. So class A is loosely coupled to class B if the only information class A has about class B is whatever class B expose through the interface. So through its interface, this is not that Java interface, yeah. So this is an API. We are talking about API. So whatever the class B expose through its API to class A, that's the thing that we just need, and that's a good thing, and we call it loose coupling. This kind of dependency is fine. But if class A has more than this, more information than this, then it is called tight coupling. All right. So when we can say this, when class A knows how the class B was implemented. That's the bad thing. Yeah, we should prevent that. Okay. So just as an one taking one example that you are familiar with for the tight coupling is inheritance. When you inherit a class, yeah, there would be a tight coupling between these two guys. So it's a A, then this is B, then B is tightly coupled to the class A. Wherever you put this B, you need to put the A as well. So I mean you transfer the A, both of them at the same time. There is a very tight coupling between these two guys. Okay, so based on this definition, just we said here, and based on the definition that we gave you for the law of Demeter, so law of Demeter is trying to make the loose coupling. Yeah, when it says that, hey, you should not call the a method from another object inside the class B, so it means that we are trying to limit the coupling to a loose coupling. Okay, so this will be more clear or clearer when I take an example. All right. So now let me ask this question: how can we remove the law of Demeter violation? Yeah, we took the example. So let's focus on that example. Let me explain via that example. So we have two scenarios here. How can we remove the law of Demeter violation? We have two scenarios. So if, in the first scenario, inside the class foo, if we just need this method from the object B, if the only reason that we are adding the class A, and then inside that class A we have an object B, and inside that B we are calling this guy. If this is the only thing that we need, then it means that we really don't need the class A at all. So we have dependency to class B. All right. So in this case, in this scenario, if this is the scenario, really we need to have dependency only to class B. So just remove the dependency from the class A. Okay, so very rarely this happens. You know, it means that if this happens, it means that our designer was a very rookie designer. Okay, but just in case, let me show you the how the code looks like. So this is our original code. So we have a dependency on class A, and then we instantiated it here, and then we are calling the get object B from the object A, variable, and then inside that we are calling this guy. So if this is the only method that we need in the foo class, then the class A is actually useless. We have dependency to class B, right? So in this case, yeah, we just change our dependency inside the foo from class A to class B, and inside the class B we just call that do something, right? But as I said, this is rarely happen. So a developer does not know exactly that this class A is we need to add this class A because we want to get access to class B. This is nonsense. But I mentioned it just in case. So in scenario two, it happens. It means that we need class A, and we need, to call the method of the class B. So in this case, to remove the violation of law of Demeter, we create a wrapper inside the class A. Okay, and this wrapper's job is to hide the class B, and it means that we don't need to get the object of B, and then inside that call the method do something. All right, so how can we do that? Here is the code. So inside the class A, yeah, uh, we create, let's say, do something A method, right? Inside the do something A, we instantiate the B. Actually, of course, we can use the dependency injection and this kind of thing that you are familiar with. But for simplicity, let's say we instantiate class B here, and then we call the do something B and return it inside this method. So we are talking about the class A now. All right. So and after this, so this is a wrapper that it has access to do something B inside the class A, right? And after that, inside the foo class, we just need to instantiate class A, and we call that wrapper method. Okay. So we know that do something A inside the that method, it is calling the object B. I mean, do something B of the object B, right? In this way, we are just calling the class A. It's not the case that we have a dot and then blah blah blah. Yeah. So this is the how we can remove the violation of uh, the law of Demeter. Okay, so what we get, the benefits, you know, the readability will increase. The code will be understandable easier. So we are increasing the readability. Yeah, when you have some, some dot, yeah, when you call this and then you call inside that you call another class, another class, another class. Yeah, you just see how complicated will be your code. But with law of Demeter, you are in your class, you are just involved with one class. And if there is another dependency, that's the responsibility of this class to take care of that, right? So here you just call the method, one method from here, one method from here, right? So the readability of the code will be increased definitely. Reusability of the code will be increased as well, right? So what is the reusability? Reusability is so you have a class, so it takes care of its dependency by itself, right? You don't need you as the user of this class to take care of those in in uh, the dependencies for this class. Yeah, so this class is in charge to take care of its all of its dependency, and here you as the user of this class just call one method from here, right? And the rest of that should be taken care of by this class. So reusability of this class will be increased, and of course testability of the class will increase as well. So when we have a code that highly or tightly coupled with many other classes, it is hard to create a test case for that. So just imagine that this class has dependency to this, to this, to this, to this, right? And then you want to test this class here. So this is your tester, right? So if it is not written a nice code here, then you need to provide the in instantiation for all of these classes in your test case. So if the code is not written correctly, but if this class has, even though it has dependency to, the other classes, but if it it takes care of the all of these dependency inside here, then you as the tester, you just need to, provide some information about this and just test one class. You are not concerned how to instantiate this, how to instantiate this, and so far. Right? Okay, so the testability will be increased definitely, and definitely the maintainability of the uh, code will increase. So law of Demeter is an important law for implementing the code, right? And we get all of those four important parameters that so far we have seen these four parameters many times, right? And you just remember that one more time, if the code is not maintainable, it dies. Okay. Now, I need to tell you some caution here. So just look at this code. Yeah, when you look at this code, do you think that it is a violation of the law of Demeter? Not necessarily. It means that law of Demeter is not the case that you need to count of these dots and say, oh, if it is more than one, so oh yeah, this is a violation of the law of Demeter. No, that's not the case. Maybe all of these are inside only one class. Yeah. So the number of dots is not a criteria for violating the law of Demeter. We need to know that these dots are coming from where, right? So if this is the case that so that dot is going to another class, that will go to another class and this kind of thing, this is a uh, violation of law of Demeter. But you can write some code, some methods that it returns something. So and then you can call another method here, and then by dot you can call another method here, and that's fine. Or even inside this guy you can call another method from here and here, that's fine. But law of Demeter is prohibited, more than one class. All right. Okay. Yeah, this is the explanation for your reference. And just as a brief history where this law of Demeter is coming from, so there was a project called Demeter in 1987 in this university, Northeastern University, and they were working on the aspect-oriented programming. So, then they created this law based on the what experiences that they had inside that project. So Demeter is coming from that project, and also Demeter means a goddess of agriculture in the Greek whatever they had in their stories and histories. Yeah, yeah. So let me summarize that. In some articles and books, you might see this description of the law of Demeter. So, in a plain English, law of Demeter is saying that only talk to your immediate friends. Yeah. So, immediate friends, only this. Or equivalently, don't talk to strangers. So if you have dependency to this and this has dependency to this, yeah, don't talk to this. This is a stranger. You need to talk to only the closest friend you have. What is serialization? Okay, so let's focus on the motivation. Why should we learn this Java serialization? So let's assume that we are game programmer and we want to add this feature in our game programming. So we want to be able to save the program in the middle of the game, and we want to resume it later, wherever that we left off. Okay, so for this reason, just imagine that in the middle of the game, how many objects are inside the memory of the computer. When I say memory, I mean RAM. Okay, so how many objects do you think that it depends on? Of course, how big is that game? It can be tens, it can be a couple of classes, it can be tens, or it can be hundreds, or even thousands of the objects inside the memory. Okay, so how can we do that? How can we save all of these objects from the memory, which is a volatile device, into a file which is a permanent thing, right? So volatile, it means that inside the RAM, when you close your program or turn off your computer, the content of the memory will gone. Okay, so we are looking for a way to be able to save these objects and also restore it. So restore or reload it, the object from the file into the memory. Exactly the same thing that we left off. We want to be exactly the same status. This is one scenario that we would need the serialization. Another scenario is when we want to transfer some objects through the network cable. Okay, so in both cases, we would need the serialization. So what is the serialization now? Okay, so we need to convert in both of them, both of those scenarios that I just explained. We need to, to have a mechanism. that we need to convert the object into the stream of bits, a stream of bits, 1 0 0 1 1 1 1, whatever, yeah, a stream of the bits, right? And this is called serialization, and Java supports this. Of course, many other uh, programming languages support that as well. Okay, so these are this a series of the bits. So the mechanism of converting objects into a stream of bits is called serialization. Okay, now the question is, how can we do that, right? I will show you via a demo. Okay, so here is just the code. Yeah, we try to implement exactly the same code. And here is the code of the restoring. Okay, now let me bring up my Eclipse and start coding. Okay, let me create a new package for this. Let's call it serial demo. And we create a class inside this. Let's call it serial demo again. Okay, everything is fine. Finish. All right. Okay, so I need two classes, car and user. Let me create them for simplicity because we want to see them. Let me create an inner class for both of them. So you remember that we said, a static nested class is better than the other. So let's create a public static class user, and all right. And let's just have a name, private string name, right? And let me create a public user, and we just pass the name, right? And as usual, we just assign the name. Okay, we are done for now. If you need more, I will add later. So another one, okay, I would need um, public static car, I'm sorry, class and car. And for the car, let's say integer, just price, for example, price, right? And all right. And for the um, public car, just integer price again, and this price equal to price. All right, so we have two static nested class here, and for testing, let me just use a main method for simplicity again. Mm, okay, so we need to instantiate these two classes first. So user, just call it user, equal to new user. I need to pass a name here. Let's pass my name. Okay, so my user class is ready right now. And for the car, again, new car, let's say $10,000. Why 10,000? Can't I drive 100,000 car? Yeah, let's make it. I'm sure that most of you say, yeah, you wish. Okay, so our job for creating the classes and objects are done here. Now my job is to, uh, you know, to store, to save these two files into a um, into a file. I mean these two objects into the file. Okay, so let me. So what was that? We need file. You remember that output stream. Let's call it FOS equal to file output stream. And we need to pass a file name. Let's call it my data dat. All right. Okay, so first we should take care of these guys and file output stream, right? Yeah, that's correct. And let's see, import Java IO. Yeah, that's correct. And what is this complaint? Yeah, well, where is the new? Okay, again, it is complaining. Yeah, it needs a try or catch. But for simplicity, again, let me throw it. You don't do that, right? Please, you don't do that. I don't want to mess up the code here with the try and catch. I just use the throw. But this is the horrible plan. Okay, you don't do that. All right, so this is my file output. So up to this point, I can write to the file, but I need first an object stream. I mean object input, object output stream. Object output stream. Let's call it out equal to name object output stream. And we need to pass this FOS here. Okay, first let me take care of the issues. Yeah, the import. And again, it is complaining. Again, I add the throws. Yeah, it changed it to IO, which is more general than the previous one. All right, for now we don't care about this. Okay, so now I have both tools that I need. Now my job is to try to um, write. Um, that would be write object, right? And my object would be, let's first I pass the user to be written, and I just copy that line and then car. All right, after writing, we should remember to close that. So close that. Yeah, exactly. Okay, so far so good. Yeah, to clean up this import, Control Shift O will clean up the imports. Yeah, let's run it and see what would happen. So if everything is right, then this file should be created in the root of your project. Let's see. Run as Java application. Okay, not serializable exception. Fantastic. So this is complaining that, yeah, you want to write the object, but your classes are not serializable. So how can we fix this? No problem. Implements serialization, right? Cool. and copy here. So all of your objects should implement this guy. Yeah. Okay. Now what? Should work. Let's see. There we go. You see? No problem. So where is the file? Where the file was created? If you are asking this, you are right. Yeah, we should refresh this. F5. Click on F5. Oops, you see it here? Okay, let's see what is inside this my data. Ah, you cannot see anything. It's garbage because it's a binary file. It's not a text file, right? But still, you can see, for example, my name here, somehow it can be hackable, right? But we are not those type of guy. So all right. So we are done here. We are done. So the written is done. Now let me show you how can we restore that. Okay, so let me create a border here. All right. So for restoring the file, we need what we need. So we need these two guys, but instead of output, we would need the input. So file input stream, file input stream equal to file input stream, the same thing, the same file, my data, that, and okay, so we should take care of the this guy. Again, new, again, new. Are you kidding me? All right, cool, yeah. And we would need object input stream, let's call it in, equal to object input stream FIS. Okay, complaining about what? The import of, oops, object input stream, okay. So the import will be Java IO. Okay, no more problem. All right. So now our job is to read them. So I need user, let's call it user 2 equal to, all right. So in read object, okay. Why it is complaining? Yeah, we need to cast it, right? Let me first see. Yeah, we need to cast it. So it means that it reads the, this guy will read the object from the file, but it return an object class. So it doesn't know that what kind of object is this. So we need to cast it to user. It should work. Yeah. Another complaint, again, the exception. Again, I am asking it to throw the exception. So this guy is adding this throw, and you never do that, right? All right. So we have the same thing for the car, and we use our laziness car2 and again car. Okay, cool. So we believe that this file now is restored into these two objects. But before going further, let me close uh, this guy. Okay, to make sure that I have um, the file is written correctly. Let me comment out this part and to just read and to show that it is really the user that I created here, Ahmad, and the car price is 100,000, right? For this purpose, I use to print ln to user2 and another one for the car too. Okay, so since I have not implemented the toString of the user2 and car2, definitely it shows me some garbage because it is, retrieving the user2 and by default it invokes the toString. But there is no toString here, right? So let me create a toString for both classes. Okay, so to have some practice, let's use the Eclipse default toString. Okay, so it's Alt Shift S and you go to here, generate toString, and it would ask you, okay, do you want to include name? Yeah, the user has just name, right? If your class has more thing, you just pick which one do you want to appear in the toString. So you see, this toString was created. All right, and another one for the car. Again, Alt Shift S, go to toString and pick the price, generate. So okay, now I have the toString, right? Now I have the toString, and let's run this and see what would happen. Oops. Okay, what kind of problem do you think it is? Yeah, I wanted to show you that actually it's a very important point here. When we were storing the data of those objects, these guys didn't have this toString. And after I stored the object data, I added this toString. So it means that the object, the class structure is changed. Therefore, the data that we stored in my data, now it's not valid anymore because these two classes are not those classes that before we had. All right. Okay, so how can we fix that? We need to read this again. So I comment out this guy and I create that my data again. And then I read that. Let's see. Okay, so this is a new, my data was created. Now I comment out this part and there we go. You see? Okay, let's get back to our slides now. So let me give you some notes here. Uh, as you saw in the demo, the the hierarchy of the classes that we are using to store and retrieve, all of them should implement the serializable interface. Okay. The second note is in some cases, you might want to hide something. For example, if you have a field which is a password, you don't want to save it in the file. Okay, in these cases, just make that instance variable as transient. Here is an example. For example, the password instance variable here, we just put a transient keyword before that, the type of the instance variable. Yeah, in that case, Java knows that it should skip the value of this field. Okay. And the third notes, as you saw in the demo, if you change the object, the structure, or even you rename a field, yeah, then this object is something else. If you have stored something before these changes, that object on the file cannot be retrieved. Okay, and also we learn we, actually I didn't mention that, but for every object there will be a unique serial number. When you use this implement serializable interface, then Java internally it can create a unique serial number for every object. Actually, that's not our concern right now, but good to know. Okay. All right. Um, we are almost done here. I just put two labs here. Yeah, the first one, you need to create two classes, user and car, and add some arbitrary instance variables, add a price. We want to check that how the transient keyword works. Okay, so just give a number, a value to the price instance variable, make it as a transient, and then store and restore that. And you will see that the price does not have any value. Okay. And I created another lab here. Just create a class cart and create an order class and aggregate an array of the card inside the order. So in this lab, we want to see how an array object work when you store and retrieve them. So this is my last lecture for this course. I wish you guys all the best in your career and your life.